I'm Don Deere, a principal of Schnabel Engineering. I'm an engineer, geologist, and geotechnical engineer. Today I'd like to speak about Chamberlin's multiple working hypothesis and the power of carbon dioxide. T.C. Chamberlin was a truly amazing man. He was a geologist, glaciologist, and a very big thinker. I'd like to talk about two of his papers today. The first one being The Method of the Multiple Working Hypothesis, which he published in Science magazine in 1890. In that paper, he talked about when solving a problem under the scientific method, the importance of investigating several hypotheses. And as more evidence and data became available, rejecting those ideas that are not supported and ending with a hypothesis that the data shows is true. This would also help you evaluate a problem that had multiple phenomenon occurring, and you could evaluate the relative importance of the phenomenon. He compared this to what many scientists were doing at the time, which he called the ruling theory, where people got locked into their offspring or their baby, their hypothesis, and just did everything, just looked at data that supported rather than giving it a full scientific test. In 1899, he followed up with a paper called An Attempt to Frame a Working Hypothesis on the Cause of Glacial Periods on an Atmospheric basis. This paper discussed the importance of carbon dioxide in the atmosphere on global temperatures. This theory was first discussed by Tyndall some 50 years earlier in the mid 1800s. Chamberlin used his studies of glaciers, his mapping of glaciers in southern Wisconsin, and his observations of various glacial episodes to theorize that when CO2 was low, temperatures were low, and hence those were the glacial periods. And when carbon dioxide was high in the atmosphere, those were milder climates. If we look at this graph, recent graph from NASA, you can see that Chamberlin was right on. Chamberlin did not have this data. This data goes back 800,000 years and is based on sampling of air bubbles in ice cores from the poles. So as you can see, when CO2 was low, you had glacial periods. You can see that recent glacial, the last advance of the glaciers there on the lower right, CO2 levels down around 180 parts per million. And when CO2 levels were around 280 to 300, we had mild climates on Earth. The recent data that is actually sampled from the atmosphere has been collected continuously since 1950 in an observatory in Hawaii, and it shows how CO2 levels have spiked to today they exceed 400 parts per million. This is another graph published by the government that shows how CO2 concentrations have increased over the last 150 years, and that temperatures, when they're shown here in red, are above normal, and when they're in blue, they're below normal, and that there's a direct correlation between CO2 concentration in the atmosphere and temperatures on our planet. I'd like to relate Chamberlin's papers to a case history. This was a project in the Central American rainforest, a hydroelectric project, which was built about 7 years ago, and leakage increased over time to the point some 7 years after it was built, there was excessive leakage. This photograph shows where the leakage was collected. It was coming out of the rock, out of limestone, which was the prevalent geology along the last 1.5 kilometers of this 6-kilometer tunnel. I was there a year prior and was able to visit one part of the underground works. This was the surge tunnel. This surge tunnel and the main power tunnel were constructed by drill and blast as a 10-meter diameter tunnel. That's very large for a hydro tunnel. And it was covered with a thin shotcrete liner. The amazing thing to me when I did the site visit was I could hear water cascading out of this surge tunnel only some few meters away. The sound was deafening of the water leaving the tunnel. At the time, the prevailing theory at the site was that leakage was throughout the whole 1.5 kilometers of the tunnel that passed through the limestone, and that all the limestone needed to be repaired with a $50 million thick, heavily reinforced concrete liner to prevent leakage. When in fact, what I was seeing was that it appeared that the leak had been concentrated. This was new data and evidence. When the tunnel was in fact dewatered for construction and repair 1 year later, that is exactly what was found, that the leakage was primarily confined to one area high up in the mountain topography above the groundwater table, and that in fact the shotcrete had been eroded out and the limestone behind it dissolved out. The shotcrete was stripped to prepare itself for the concrete liner, and lo and behold, that's what it looked like. These joints were mapped during construction as being only 1/2 inch thick, filled with a highly plastic clay. And as you can see, 7 years later, they were big enough you could walk into some of them and stick your arm and hand into most of them. This was clearly ultra rapid dissolution, but some additional information had to be gathered. So we sampled the reservoir water quality for multiple constituents. This graph shows CO2 concentrations versus depth. The deepest sampling was at 85 meters depth, and that's where the CO2 concentrations were the highest, up around 35 parts per million or milligrams per liter. And as you can see, as you go up in the reservoir, they are at zero because the CO2 is off-gassing to the atmosphere. I was amazed because I'd always thought of hydroelectric energy as being the ultimate clean energy. It's not when it's in a rainforest situation and you do not grub out and clear the reservoir of the trees and the vegetation, which was not done on this project. What happens is you get the decomposition of organic matter in the reservoir, the trees and logs, which are made up of greater than 50% carbon. And that carbon dioxide reacts with water to form carbonic acid, which it's the carbonic acid and the fact that this was very soft water. It had very little calcium carbonate within it to get these kind of rapid dissolution. So in conclusion, the prevailing theory at the site that it was throughout all the limestone was not true. The prevailing theory that it takes thousands and thousands of years to cause cave formation and major karst networks is also not true. This happened in 7 years. Now, where this happened was very close to or above the groundwater table, and that there was a existing karst network that the tunnel short-circuited with. In closing, Chamberlin, who was also a bit of a philosopher as well as a geologist, wrote in his closing paragraphs of the multiple working hypothesis paper, "I am confident, therefore, that the general application of the multiple working hypothesis method to the affairs of social and civic life would go far to remove those misunderstandings, misjudgments, and misrepresentations which constitute so pervasive an evil in our social and our political atmospheres." It would seem that things have not changed all that much since the 1850s. Thank you very much.